Okay, but we know this formula. Work is force times distance. What's the units for work? That's in joules. And power is a rate at which work is done. The faster the work is done, the definition says, the more power it is. That's an inverse relationship, P and T, right? And yes, the unit is watts. Okay, so that was yesterday. Today, recall again. Kinematics. Okay, I got a projectile shot at 40 degrees to the horizontal. I'm not even going to write it. How high does it go? And why is that physics 12 and not physics 11? Yeah, because I have components. So we've done that. This thing shot at 40 degrees. I want to know how high it goes. So what I'm concerned about is, I don't care about range. I want to know the vertical component of that speed. What speed is that? Ooh, kind of need that, right? Kind of makes a difference. 25 meters a second. Well, that's a sine component. So Vy is 25 sine 40. And it's probably rounded, but that's pretty close to 16 meters a second. That's in the direction I'm concerned about. So how did we do this? Found a formula with stuff we know and stuff we're trying to solve for, like D. Okay, and then, well, what do I know about when it gets to its maximum height? What's going on? Yeah, Vf is 0 up here. So I have 0 is 16 squared and 2 acceleration in the other direction times D. And if I solve that thing for D, well, this comes over to that side, so the negatives kind of cancel out, if you will. And I get 13 meters. So that, you might be asking, well, what the heck are you doing that for? Well, let's look at it in terms of energy. Energy is conserved. Whatever energy it has before is what energy it has after. Before here is when it's on the ground. After is when it's at the top. So the big, long, complicated formula is all its kinetic and all its potential is equal to all its kinetic and all its potential after. Without putting the little primey things here and there. Okay? And then, for this question, I want to kind of simplify. What's potential before? It's on the ground, isn't it? So that's going to be my 0 level, my reference level for potential. So it's got nothing. So I got 1/2 mv. What's v? 16 squared equals, and then when it's at the top, well, we already determined that Vf is 0. So it's got no kinetic at the top. Is mgh. And what can I cancel out? Yeah, cancel out the m's. And I have 16 squared is 2gh. And have we seen this somewhere before? Doesn't that look awfully similar to this? I.e., like, isn't that identical? It's just like the same formula, isn't it? Okay, the 16 isn't negative, it's not on the other side, but again, here for G, I'm just talking energy. I probably just would make that positive, okay? Well, D is going to come out to the same thing here, okay? Because that's the same as that. Ignoring one little minus sign. So that's another way you can solve for it. You remember, I think a review question on the Physics 11 final had a question like that. Solve it using kinematics, solve it using energy. What a wonderful question, right? More than one way you can do this stuff. So, one of the questions I gave yesterday, a few of you were asking me, or at least one of you. Okay, so that's the concept. Now, where are we going in a week and a half? Yeah. Roller coaster. Little rickety old wood one. If you're all lucky, it won't break while you're on it. Actually, that might be fun. So this thing is moving at 2 meters a second. It not free falls, but goes down 20 meters. Let's write some words. 100 kilogram. Yeah, I'm feeling pretty lazy. I don't even want to write the word roller. Coaster with initial speed of 2 meters a second falls down a hill of 20 meters. What's the speed at the bottom? And we've kind of done this before in Physics 11, but I probably had or assumed that this thing wasn't moving here at the top. Okay? So, do we see why that's maybe a little more difficult now? Just got more numbers to play with. Conservation of energy. Before equals after. Does that sound like momentum? And we could even make this more difficult and say, I'm not even going to take that as my ground level 0. It could be down here. So I still might have some potential, okay? But for our first question, let's pretend that's our 0 level for potential. Doesn't get any lower than that. So having said that, what is the potential when it gets down to here? Yeah. Okay. Now, can I say it has no kinetic at the start? No, it cannot. It's got energy here, and obviously it has potential. So, and again, do you like fractions or decimals? It doesn't really matter. Do I have a mass? Yes, I do. 2 squared, and it has potential. Of that much energy. So that energy before has to equal the energy after. So I only have one variable. Okay, 50 times 4 is 200, and that's too big for my head. $19,600 is 50 v squared. So add those, divide by that, that's v squared, so v is the square root of that divided by that. 19.9 meters a second. So am I assuming some things here? I'm ignoring friction. Is that realistic? No. So how would this question differ if, I don't know, what did I say here? Something that's going to work. Like these things roll, because it's, you know, cheap roller coaster. It's not like a Japanese one that's magnetically suspended, right? And even though we put grease on them, they're going to heat up. There's still going to be some friction. You're going to hear some sound. There's going to be some losses there. So I'm just going to call it heat. If 50 kilojoules of heat is lost, what do I do? Think of, you remember chemistry? Is this endothermic or exothermic, this event? Yeah, heat's given off, right? It's like a bomb blowing up. It's exothermic. It's giving off heat. So that goes on, does it go on the reactants or the product side? Product side, yeah. You're going to add that here, right? It's given off. That will reduce this. I got to subtract that. If you're saying, yeah, I got to subtract it from here, yeah, this is what you're doing, right? You're just thinking one step ahead. Well, that's kilojoules, isn't it? I don't know if I wanted to put kilojoules. I think I just wanted joules, because that doesn't make any sense. Joules, that's not very much. Anyway, okay? This is obviously going to reduce my speed, isn't it? Yeah, not by much. Well, according to this question, but it should make sense, right? This is ignoring friction. If there's friction, well, obviously it's going to be going slower at the bottom. Okay? So, I'm just emphasizing, if you get this, which I'll give you some questions with, then you got to just add it to the right side of the equation. So now you can do 4, 5, 6, 7. Why did I split that up? 5 is, it's worth looking at, but it's not something I'm going to put on a test. Okay, you'll understand what I mean when you see it. 11, 14, and 17 to 19. Alrighty? Having said that, who's got accelerometers on their smartphones?